So I'm Christian Killer. I'm from Acurast Association, and I'll talk about unleashing AI without big tech, a hands-on deep dive into decentralized compute. It will be semi-hands-on because I recorded parts of the demo just to keep it short and crispy. Let's dive right in. So compute and power demands surge, mainly driven by AI. So this figure you see here is from an academic publication where you can see the floating point operations are increasing by the year. And the elements you see is like different models that are being computed. So just from that figure, and there's like tons of other publications on that there's a huge increase in the demand of compute. And also power, therefore, because like data centers eat a lot of power, and that's an issue, especially midterm and also long term. Then the usual Web3 pitch, but with a twist, because some people might remember this phrase. There's no cloud, there's just other people's computers. If you really think about the infrastructure of the internet, that's unfortunately the case. And the only thing we can do is in that regard is trust others. And we sort of built this feudalistic system where maybe 5 players have the power. I mean, that's why we're all building in Web3, because you want to fight this centralization bottom up, right? Just to emphasize this even further, cloud computing is super monopolized. We have a few players that literally own like 80% or 90% of the whole market. And even if you go look further down the rabbit hole, the leftover percentage is maybe even like owned through mother companies from these big 5. They own your data and enable the mass surveillance of all of us. So with AI, this has become even worse, which means that these huge AI models were prone to overfitting back in the day. But now with LLMs, might not be the case anymore. And the more you feed to it, the more you can actually build these models out. And as we can see now also in the publication side, these models keep getting better and faster and bigger. And yeah, so it's just out of control. Clouds also pose a supply chain risk. So if you ever thought about like risk assessing your business model, which nowadays nobody does anymore, because you can just sweep the next hack under the rug since everybody's used to it. But let's look at the bigger picture. Like if you rely on clouds in your business model, then you really have a supply chain risk. If you're either being censored or maybe blacklisted or hacked, right? Oops. And then clouds are not censorship resistant, which especially now with new political developments might be interesting what will happen down the line. And they're sort of hard to localize because they're global players. I would argue they're like as powerful as nation states, especially if you take 2 or 3 together. And then they can actually influence geopolitics really heavily. And then one thing that's just a practical example of all these theoretical pinpoints is that there's these sub-processors on Google. This is a huge list that I just scrolled down. And all of these sub-processors, there's, for example, part of the support process with Google Cloud, which means they have access to your data. So yeah, it's not just one entity, it's thousands of entities. Now, what do we need? We need a global scale cloud network founded on open source principles. I'll leave this quote here. Open source is enshittified and open does not necessarily mean verifiable, which is a problem for cypherpunk values. Cypherpunk nowadays is probably more a hashtag and a thing for cool kids to show off, but actually the values should be more important in the times of meme coins on Solana. But yeah, in a nutshell, this means that even though something is open source, it doesn't mean that it's verifiable. So you need to actually have, for example, if you have a ZK system and the prover is not open source, then that's quite hard, right? So Second of all, this quote, which is a historical play on another quote of Thomas Jefferson, I believe. In words from history, let us speak no more faith in man, but bind him down from mischief by the chains of cryptography. So I think this is sort of what we think of should be the ethos behind a global cloud network. Here comes Acurast. So we already have 40,000 devices onboarded as of today. We're hitting sort of exponential growth in the device onboarding, and that means that we really have the supply side fully covered to build such a network. This is really distributed across the globe, really decentralized. And as you can see, people are going crazy with farms actually clustering together these devices, which is super nice because they can be connected through USB-C with I don't know how many gigabytes per second, which also sort of solves the latency issue if you want to have like compute being done across multiple devices. So why use mobile phones and why this approach? Because they're secure by design. If you look at the R&D expenses of mobile device manufacturers, then you can see that there's billions and billions being spent on that. And if you're not a nation state actor, it's really hard to get into such a device. Of course, there's Celebrite and all these technologies that enable that in practice. But if you fully lock down a phone, an Android phone, for example, you really have these ARM specific chips and also external co-processors in the case of Google Pixel that are really, really safe and secure. Everything is safe and secure until it's hacked, right? So we don't have any illusion about that, but that's why you need a heterogeneous network and not just the same device. Then it's also decentralized by design. As you can see from this stat here, we have almost as many smartphones as people on this planet, which is quite insane. If you just think about the trash also, because like people keep buying new phones. So there's another way to make use of these resources by upcycling them. So there's many people that actually have bought up the whole market in Switzerland and other countries from broken screens phones that were resold on the secondary market and then put them to work for our network. Then it's also scalable by design, which means that not scalable by design, yes, because we actually have a huge supply side of mobile hardware being sold. So instead of just buying single-use hardware, you can actually, if, for example, the demand would crash of Acurast, then you can just resell these phones and people can use them as phones, right? So it's not like a server that you can just use for compute in a data center. Then, of course, nowadays everybody talks about AI. When you walk through ETHDenver, it feels like an AI conference. I'm not going to claim I was the first one that did decentralized AI, but like everybody's doing it now, which is superb and nice because you have these different approaches. And I think two things are important here for me especially is that it's a heterogeneous device network that is you can actually confidentially use, which means that, for example, if you say use 10 devices, then you can end-to-end encrypt all the communication and computation is being executed inside of the trusted execution environment of the device, and then you can fetch the results. So if you want to do this on a cloud, AWS, you need to sort of trust their HSM, which, of course, I'm not saying our approach is much better. It's just a different trust assumption. You just need to trust the hardware producer, and in the other case, a more obscure proprietary provider, right? So, and I think global scale and heterogeneous network is the way to go here because you can also hedge against the issue of having the same type of hardware everywhere. How we can do this is one example. I will show a quick demo after that I executed this morning. This was one demo done by our co-founder Alessandro, where he deployed DeepSeek. I don't remember exactly which model. Of course, not the big one. So on one device, and then directly executed the query and received the answer. So in that case, you can really be sure that only in that device the query was processed and you directly received it, which is pretty nice. And it's not being traversed through data centers in and out. On the dev experience side, we have developed quite some things now. We have the console, which I will show quickly right away afterwards, and the CLI, which makes it much easier to actually try it out and deploy things. And especially now, since things are subsidized on the testnet, you can try it out, fund your wallet, and just right away roll with it. This is the end of the presentation, but I will quickly show you a demo as well. This is our Rebellion program. Yes, please.
That CLI, how similar is that to like Bash?
I will show it to you. So if you scan this, you will land on our Rebellion program, where it's a typical task loyalty program kind of thing, where we engage users to actually do meaningful things to grow the network. And then that's just me directly down there. All right, let's look at it. Okay, so this was done this morning. I don't know if you can see it. Yeah, now it's visible, right? So I had to, of course, npm run build. So it's a standard JavaScript repository where we have a front end for an LLM and also sort of the Acurast script that is needed for the LLM model. So run build, I'll just show also the package JSON so you can see the Acurast CLI is one dependency, then local tunnel express, Node Telegram bot APIs to have reporting as well, sort of standard stuff. And the most interesting thing is you can also steal my testnet seed here. So in the env you actually have
the video. So
exactly. Here, that's the interesting part. Down here, deploying project LLM using the following address. Then when it's scheduled, so it was 7 in the morning. Yeah, I have jet lag. I was awake at 3, so that's why I did it then. There will be one execution with 10 replicas. That means that you have the same deployed on 10 devices. Unfortunately, only 2 acknowledged. I didn't debug that in depth, but you can also see the costs. And essentially, then it's done. Then you can go to the console here. And the deployment from this morning will show up. No. Yes, here. That was this morning. You see the time is equal. And you can see there's many different parameters that you can play around with. So the duration can be defined, the interval can be defined, how many executions, how many processors. Unfortunately, only 1 worked, even though 2 were assigned. You can see 0 of 1 executions. Then you also don't pay for it, of course. So if it's assigned and the processor doesn't really deliver on it, then you don't have to pay for it. And then I think I used this one. Yes. Yes. I copied this address, and then we have a proxy on our end that actually, I'll show you. So here again, I show just in progress. So that was this morning. Going through the same thing again. I don't need to show that. Yep, that was the one. Copied to clipboard. And then you can see our proxy then relays it directly to that device. And then one thing I get asked often is, what is adaptive inflation? So I thought, why not let it explain? And I would say performance-wise, it's quite feasible. Like it's comparable to ChatGPT if you use the front end or the CLI.
Do you know how many parameters were in that LLM?
I can check afterwards in the repository. I can also give you the repository because it's not public. So yeah, that's more or less it. I don't think I have anything else here to show. I mean, I could show the repository here, but it's quite, basic. If you have any other questions, feel free to ask, please. You need this?
Yeah.
There's a mic inside.
Yeah.
Nice.
It's not only a token, it's a mic. The mic token.
Nice.
See, I have a question. I mean, it's a bit technical question, but
Go ahead.
You mentioned that you have 10, with this task, you have 10 nodes, like waiting. I don't know, I don't remember the exact words. And then you launch the task, or like, hey, guys, this is something to be done. And 2 of these nodes accepted the task. One made it, this result, and the other no, but other problem. But how this works, if I'm a user, how I decide which task I want to have?
Okay.
Some marketplace, or I mean, my task, of course, because that's what I'm using the devices. But how this works?
Good question. Yeah, I mean, this is the core mechanism of the chain, right? I didn't explain it at all. So let's start from the beginning, from a deployer side. Essentially, you define all your parameters. I didn't show them also in the example because you can define how long, the interval, how many devices. And also what is missing in the testnet now is a reputation. Because devices, if they execute and are online and have low latency, they have good reputation over time, which is what we don't have in the testnet, which is why not everybody executed it, right? Even though they took it off the task. So basically you publish.
More for the ones with good reputation?
It will be like a market, free market, exactly. They can demand more. They can say, I want minimum this, minimum that, for bandwidth, for storage, for everything. So then you post this as a transaction, and then processors can take up this and accept it also on chain, and then fetch the compute and actually execute it. So that's the life cycle from until then. And then also after execution, there is an execution report, and only then the reward is being paid. So you actually have to sign this execution report and publish it as well from the processor. And in this case, although 10 accepted it, only 1 executed it. So I would have to go debugging now why. Yeah, exactly. But with the reputation system in place, then this would not happen because, right, because you will choose people that actually will be available. Right. And then there was another question.
I have another question. And you show that there's 40K devices already in the network. What they are doing? What tasks are doing?
It depends. Like they're being, every hour they need to do a heartbeat. And this heartbeat is persisted on chain, which means, hey, I'm online, right? And they're being incentivized for that by us right now to have like a baseline availability. And then we have one specific use case is for oracles that are being used also in production for DeFi projects. One of them being on Tezos. And then another use case is that is being deployed or was being deployed last week is that the wrapping of Bitcoin on the Tezos network was also sort of bridged through the signers of I don't know how many devices. So the whole algorithm of sort of bridging Bitcoin and wrapping and unwrapping it is also done on Acurast. And it's around 200 No, now it's about 100 million in Bitcoin. Exactly. Yeah, and there's also oracles on Ton Telegram network. Somebody implemented that. Yeah, and tons of other things that are being developed right now as well. The main challenge is actually to work with the latency, etc., and also the debugging is a bit harder because you work with a confidential compute engine that doesn't leak anything unless you tell it to tell you what is happening, right? So you cannot just give the log to everybody, but it has to be very thought out. So,
but I found it very interesting that this, like, the example that you mentioned about these people doing the wrapping and unwrapping of Bitcoin. So basically getting out of the official grid, I would say, in that sense, because they are trusting Acurast, that these people of the phones, in the sense of the army of the people of the phones versus the feudal lords with the. So it's like it's a cyberpunk approach in the right way, in the sense of what are my other ways to do distributed computing?
Exactly. But I have to be a bit less cypherpunk there. So basically, one thing that you can do, what I really like, because I was researching voting systems before. And one problem that I had was sort of retrofitting Ethereum to be proof of authority and then have only trusted authorities signing blocks. Then I worked with Substrate because it was much more better to customize. And here you actually have an even better abstraction of that, because you can say, hey, I only want these devices to be trusted and only they will execute for 7 out of 8 maybe. And the 8th multi-sig participant could be some random guy from the network, right? So, of course, in the testnet, it's not feasible to work with production assets. So we have to use trusted people. We know they keep them online, etc. So, but I think if you have stuff, for example, that where you have bigger sets of signers, then it's definitely feasible to use the public network. And also, one other thing that I didn't mention is that the metadata of the devices, we actually know about what kind of device it is, what kind of chip it is. And depending on the threat model, you need to know on which chip is this being run, not some cheap $10 phone, right? Which doesn't have a TE.
Yeah.
I'm using TE on purpose because I know there's terminology we could talk on for days. But the HSM, or whatever you want to call it, external coprocessor. So let's say I want to use something that is securing hundreds of millions of Bitcoin. I would use only Google Pixel 9 newest iteration, right? So that's also important side note.
You can use this threshold. It's like if my task is for this latest version of Android, for example, because maybe there's a software vulnerability, and this minimum chipset version of the phone.
You can't do it right now, but we have the data. It's just a matter of, yeah, exactly. It's not, I mean, we will do this. It's not a matter of whether we want to do it. I think it's just the only way it evolves, right? Yeah. Thanks for the question, Darren.
This might all be above my head a little bit, but like, how powerful of computing are we talking about? Like,
I don't know the latest number in my head from if you would calculate everything together, right? But we also have that data because we have the device data. We know how many gigabytes of RAM and terabytes of storage. But per device, you can just look at Android devices, because we can fully lock down the Android devices and actually use the full compute. It's not like on iOS where you have an app and it's in the background. It's not that performant, right? You have other stuff running. So coming back to the original question, there are phones going up to 32 gigabytes of RAM, I think. That's the maximum right now, or 24. So that's basically replacing like 2 or 3 servers if you use that specific device. And you use mainly compute, CPU, and storage, and bandwidth. GPU is another story. As we all know, that's also another market that is completely crazy, with these H100s going for 5 times the retail price. So yeah, I hope that answers your question.
Yeah.
as we evolve in this space, because Moore's law is still working more or less. It's flattening probably a bit with the nanometer technology not being able to go smaller. But with ARM, we have still some boosts left. So, and most of the developments of hardware are going always first into mobile, because there is a huge market. And power efficiency is most crucial, so that everybody can spy on us, right, all day. It's very valuable. So I think there we'll see phones going up to 120 gigs of RAM and more cores easily. Yeah.
And given my non-technical nature, and I saw, I think, a flash of like Acurast Lite, there's basically a user-friendly version of this to set up.
I mean, also the other version is user-friendly. It's really easy. You just need to have so just to explain it straightforward, if you have an Android phone, you need to factory reset it, click 4 times on the screen, and then there will be a camera. And then you can scan a QR code from your console. Let me show it quickly. So in this account, I don't have any device, but you can just add new device here. Then enter the password, which I don't store on this computer, of course. And then you would be able to, you can even embed your Wi-Fi network
Nice.
in the QR code, and then it's
okay. But it has to be factory reset. It has to be a devoted device for
on Android. Now, the second part of the explanation is that the Lite version is the one on Apple, because Apple doesn't allow us to fully lock down the phone, of course, unfortunately.
Yeah.
Not yet. That would be nice, though. I think hardware-wise, Apple, if we could fully lock them down, then it would be another game. So there, it's just in the background, an app that is only running when it's not in the background. Then you're providing the compute. So that would be very easy. If you sleep, plug in the iPhone, and then you get the rewards. Yeah.
Amazing. Thank you.
Thank you for the question. And also, token launch is coming soon, and also mainnet launch is soon. I'm talking about 1-2 months. So.
So people are basically paying for compute with the tokens. That's the utility of the token. Is that right?
Exactly. Yes. A part of it is burned, and 30. Yeah, part of it is burned, 30%, and 70% is rewarded. Exactly. Thank you.